So in lesson 3, we're going to look at quadratic functions again. So you're seeing the same shape, but we're going to see them in standard form. Now from last topic, you remember that standard form means the exponent or power here is in descending order. So we have a power of 2, a power of 1 that we don't write, and then no power. So this will always be the form if we're talking about something for standard form. But why is it useful and what does it tell us? So take a look for a second here, and you see the colors of the graphs and the colors of their equations that they go with. We can tell the first two parts of the standard form equation are the exact same. So what's the difference, and what does it tell us on the graph? You maybe noticed that this -3 here, because you know it goes with the black graph down here, is also what we call the y-intercept, or the -1 y-intercept on the red is the -1 here. This is always the case, that if your quadratic functions are in standard form, this last number, or what we call the c value, is the y-intercept. And so that makes an easy piece of the graph to graph quickly. Now you might wonder why this is. Notice how all of these y-intercepts have an x value of 0. That's because if we put a 0 in for, let's say, the blue one, -2 times 0 squared, plus 4 times 0, plus 1. Anytime I multiply by 0, these are going to go away. So our only answer left is 1. That means when I input a 0 to the function, I get out a 1, and it will give us our y-intercept every time. So let's look at this example 2, and we're going to graph. One thing about a standard form of a quadratic is it will always look like ax squared plus bx plus c. And that c value is what we said here is always the y-intercept. So if I look at this equation, I know my y-intercept is 3. And I can plot that right off the bat. I'll put that on my paper here. Oops, a 3, sorry. Okay, so now the tricky part is we want to find the axis of symmetry in the vertex. What we're going to use for an axis of symmetry, this is our equation, and so I'll write it up here. If you want the axis of symmetry, I'll abbreviate here, you're going to use the formula x equals opposite of the b value divided by 2 times the a value. Now again, the a is in the first spot, the term before the x squared, and the b is the middle term. So for this one, we would say your axis of symmetry goes through the opposite of this b value. So instead of b being 4, we're going to call it -4 for the equation here, divided by 2 times my a, which is 2. Well, -4 divided by 4 is a -1. That means my axis of symmetry is -1, and I could come and draw a line down at -1. That's my mirror, if you will, the center of my parabola. Now we can look at this a value, and we know that since 2 is positive, it's going to be an upwards opening parabola. So we know we're going to have some sort of down and then up parabola. How do we find the vertex, though? We know that if you have a parabola, your vertex will cross with your line of symmetry because it's the middle turning point of your graph. So we're going to put -1 into this function. So we would have, or substitute, -1 in for every x squared. Now, order of operations can be a tricky part, but we want a -1 times a -1. We have to square first. So I'd have 2 times 1, which would be a 2. 4 times -1 is -4, and add 3. When I input a -1, I'm going to get out a 1. So that means my vertex is at x value was -1. That's from here, what I put in there, because that was my vertex, or I'm sorry, my line of symmetry. And my y value that I got for the output is 1. So I can plot that coordinate -1, 1, and that's my turnaround. Now, if I connect those 2 points with a line, we know that's not going to make a quadratic function. So to put another point on this parabola, since we know it is a parabola with symmetry, we could easily say this is the other point, so it makes that balanced mirror. And I could finish my graph opening upwards because that a value was 2. So this other point that I graphed was negative 2, 3 because it was another step over and up to just as this y-intercept was. You could try another one much like it. Again, you would just say, like, for example, on B here, we know this is going to be a negative sad parabola. We know our y-intercept is negative 4. And I would be able to find my axis of symmetry by doing x equals the opposite of my b, which is negative 3, divided by 2 times. Remember, this a is negative, so we want to put that negative 0.75. This would be negative 3 over negative 1.5, and that would give me a 2. So my axis of symmetry is at 2. We'll draw that down here for x equals 2. And then I would plug in that 2 into this equation and substitute 2 squared and 3 times 2. And after doing that, I'm not going to show the work on here, but it would come out to a 0. So I would plot 2, 0. This so happens to be the x-intercept also. And to get this other side, I'd have to balance it. How it's 2 steps from the line of symmetry. It's 2 steps out over there. So I would have a sketch of my parabola. Oh, missed it. Like that.